My dear friends, today I am going to explain the transistor is an amplifier. What we mean by amplification? Let this box, it is an amplifier. If I give this signal very weak, very small in amplitude, this is an input giving to amplifier, and in turn, if amplifier gives me this type of signal, then this box is said to be an amplifier. Mean weak input, very small amplitude signal, and the amplifier is giving us a very high amplitude signal. So this is an amplification. Now inside the box there is a transistor. Now how the transistor acts as an amplifier, this is our problem. Okay. And before going to discuss that, I'll try to give an analogy. It's a silly one, but it is good. Imagine a very old woman with very feeble voice, okay, who is giving a speech to a vast audience and no loudspeaker allowed. Naturally, no one can hear one word of her speech, even a word of her speech. But a man sits behind her and listens to her speech and speak the same in his own voice. In his own voice means with a strong voice. Now the audience can hear the whole speech. The woman's voice is the signal, the incoming signal. Okay? And the man is this box, this amplifier, this transistor. And his voice is the amplified voice. Now consider an arrangement. Like I am having input voltage and input voltage may be 0 to 50 volt, let's say, and I am giving this input voltage to the two resistors, the resistor R1 and the resistor R2. Okay, and I am getting an output voltage across here. Output voltage, that it is V0. This input voltage is Vi. As I already explained, this is my input voltage, 0 to 50, suppose, connected with the two resistors R1 and R2. Across R2, I am getting the output voltage. Now, what is the relation of output voltage with respect to the input voltage? Very simple. First of all, you find the current flowing. That current is I equals to Vi upon R1 plus R2. Then you find out what is the voltage across here by Ohm's law. The output voltage is current multiplied by R2. So what is the current flowing? Substituting the value, V0 becomes, the current is Vi upon R1 plus R2 into R2. Now the different cases. If my R2 equals to 0, if R2 equals to 0, then output will be 0. If R2 is equals to 0, output voltage is 0. Number 2, if R2 is very much greater than R1, then R1 is neglected from here. R2 cancels out. This neglected cancels, and output follows the input. Third, if R1 equals to R2 equals to R, now this becomes 2R, this is R. RR cancels, like V0 becomes VI upon 2R into R. The output voltage becomes half of the input voltage. So you'll get half voltage if the resistors are equal. So from here what we learn, if the resistors are equal, you are getting the half voltage. If R2 is very big, you will get approximately equals to the input voltage. Okay, and if R2 is very less, negligible, then you will get no voltage. The voltage is according to R. Let if R2 is variable, you will get all the voltages of any value. You get voltage of any value if R2 is variable. Right? Now I'm coming to the transistor. Now I'm using common emitter configuration. This is R1. This is input voltage. Here I am getting output voltage. This one is base ammeter, and it is grounded. Now this arrangement is same as this arrangement. These VIs are connected here. R1 is fixed. This collector to ammeter, the resistance from collector to ammeter, it is R2. So let's come to the case number 1. If the transistor is off, means no signal voltage here. This is off. Then what happened? Not conducting. Transistor not conducting means very big resistance. So this is very big resistance. Very big resistance, I already told you. Here the voltage will high. So this is off, transistor off, and V0 will be very high. Now when you give the signal, this becomes on. Transistor on means it is conducting. When it is conducting, it behaves as a very low resistance. Very low resistance means this resistance goes down. This resistance goes down. What happened? The output voltage will go down. So when the transistor is on, conducting, low resistance, voltage falls. Means voltage decreases. Voltage decreases means approximately, let's say 0. When off, the output voltage is high. When transistor is on, output voltage is 0. This what's happening. I'm going to make it variable. Instead of 2 stages, on and off, I'm going to make it variable. How? Let I give some biasing here, N, P. To P, I'm giving some biasing, like positive, negative, and then signal. I apply the signal also. N, P to positive, and I'm giving microampere current. Okay, when there is no signal, When there is no signal is not applied, the current it is in microampere. Means there will be some value of this resistor. The transistor is in conducting, but not to the extreme cases. The case it is in between, like when R1 and R2 are equal. Here the voltage is half of the input voltage. So let's say I'm given some voltage here to the base, some base current. With some base current, there is with IE equals to IB plus IC. If there is base current, there will be collector current. And there is collector current, there is some resistance here, collector to ammeter. And that resistance, suppose, equals to R1. Then here the voltage comes out equals to half of this voltage. So that is my reference level, suppose. This is my reference level because without any signal, I'm getting some voltage. So let my base current is, with this base current, let us say my base current is 46 microampere. And some collector current is flowing, and collector current is suppose 4.8 milliampere. And ammeter current will be slightly greater. I'm not concerned with that. Okay, I say 4.8 milliampere. Then what will be the voltage between collector and ammeter? Okay, and that voltage is 5.8 volt. Okay, now when the signal comes here, signal is varying. Now I'm giving the signal here. With my signal, the base current is going from, it is approximately 50 to 80 microampere. When the base current is going from 50 to 80 microampere, the collector current will go 4.8 milliampere to 7.7 milliampere. The collector current will go 4.8 to 7.7 milliampere. And because the base current is increased, that is more conduction. More conduction means less resistance. Less resistance means here the voltage falls down. So collector ammeter voltage before it was 5.8 volt. Now it goes to suppose 2 volt. It goes down. Okay. Now the signal, it is increasing 50 to 80 microampere. Collector current is increasing 4.8 to 7.7. Well, base current is increasing. Base current is increasing 50 to 80 microampere like this. And collector current is increasing 4.8 milliampere to 7.7 milliampere. Mean collector current is increasing 1,000 times greater, almost. So collector current also increasing like this. And collector ammeter voltage 5.8 to 2 volt. Now it is decreasing like this. Collector ammeter voltage going 5.8 to 5.8 is our reference level. It is going to 2 volt. Now again, the base current is changing from back 80 to 50 microampere, like this. The collector current will go 7.7 to 4.8 milliampere, the reference level. Now again, because The collector current is decreasing, less conduction mean voltage will go high, mean 2 volt to 5.8 volt. Okay. Now from 50 to base current, it is going down. Okay. Let it go down to 20 microampere. When the collector current will go down, mean less conduction. Less conduction means this voltage will increase, and the voltage will increase from 5.8 volt to, now it is going 5.8 volt to 9.34 volt. 9.34. So it is like this. So this is the case that my base signal is swinging in microampere, but the output voltage is swinging. 5.8 volt is the base level. It is swinging. 2 volt is lower level. 9.3 is the upper level. So just see how much the signal. Just see how much it is amplified. The signal is amplified. Now the same I am going to explain with the help of the graph. Now I am coming to the actual circuit of the transistor. Now this is my transistor. Okay, NPN. Now there are two resistors. There is a supply. Let this supply is 15 volt. Okay. Now there are two resistors are connected here, R1 and R2. What is the function of these two resistors, R1 and R2? R1 and R2 forms a potential divider that brings the base voltage about a reference level, a fixed level. Okay, like in my case, this R1 R2 giving a base current equals to 50 microampere, which is my base level, which was my base level. And if you just see the output characteristics, so my base current is fixed now. The base current is 50 microampere, and with that there is some collector current and there is some collector emitter voltage, IC and VCE. So R1 and R2, it decides the base current and the base voltage or the reference level or the Q point. Q point, it is by R1 and R2. Now there is a resistor RC and RE. This is the emitter resistor. So transistor RC potential divider with RE. What the function? Okay. It provides the negative feedback and stabilize this Q point. Q point stabilization is connected with RE and RC with the transistor. Negative feed, there is advantage of negative feedback that the Q point becomes stable, but at the cost of some gain. Okay, some gain decreases with negative feedback, but otherwise our Q point becomes stable. Now there are the two capacitors. Here there is a capacitor that it is C1, and here it is a capacitor C2. What is the function of the two capacitors? C1 and C2. So C1 and C2, they are the two capacitors. They isolate the DC voltage in the circuit. Okay, it isolates the DC voltage like 15 volt and different voltages, DC voltage at here. Okay, isolation of DC voltages from the AC signal. And there is also capacitor here. Capacitor at the emitter, CE. CE can be used to bypass the negative feedback for AC frequencies of interest. Because here the voltage, DC voltage, it provides negative feedback. But we don't want any AC signal feedback. So to avoid AC frequencies feedback, we connected a capacitor CE. Okay, so this is a function of CE, not to provide negative feedback by the AC signals. So this is all about this circuit. Okay. So this is a graph between collector emitter voltage along x-axis and collector current, it is along y-axis. Red line is our load line. This is a Q point. Q point is such that here the base current is 46 microampere, and this base current is without any input signal because the transistor is given a potential divider arrangement with collector supply, and with that there becomes some forward bias voltage at the base, which is providing 46 microampere, approximately 50 microampere current without signal, okay, with the potential dividing arrangement, or we say with biasing to the base circuit without any input signal. Now when the signal comes and it swings like this, okay, when it swings like this is a swing of the incoming signal, and the base current, it fluctuates 50 to, this value, which is, notice, 80 microampere. 50 to 80 microampere, 80 to back 50, 50 to going down. How much? Like you are going in this way. This is going down to how much? 20 microampere, then 20 to back, normal value, which is 50 microampere. Base current is related with the collector current. As a base current going up, collector current is also going up from 4.8 milliampere to 7.7 milliampere, then back to the normal value, then going down to 2 milliampere, then back. So collector current swings accordingly as the base current is swinging. Now notice that when it is going high, collector current is going high, but the collector emitter voltage will go down from 5.8 volt to 2 volts. Then when it reaches back high to normal, then it goes from low value to the normal value. When it swings in the negative half collector current, but collector emitter voltage swings in the positive half, like going from normal 5.8 to 9.34 volts, then coming back. So in this way the amplification is achieved because base current, it is in microampere, the very, very low current as well as very, very low voltage, okay, very dim voltage, very low voltage, but output voltage is very good in volt, and with that the amplification is achieved. Okay, thank you. Thank you so much. My WhatsApp number 9888169226. If you have any difficulty in electronics of any subject, any topic, you write me on my WhatsApp number. My name is T.S. Mahajan. Okay, thank you.